All right, today we're going to continue to look at volumes. Yesterday we looked at if you want to find the volume of rotating around the x-axis, you're taking the area of the circle, which is pi r squared right here, with our radius being the function. And then the width of this cylinder is change in x, or dx. And so if you integrate all those cylinders from A to B, that gives you the volume. Similar, if you have two functions where you're where rotating it around the x-axis gives you some sort of washer type of cylinder, then it's the same thing. You're subtracting the outer circle minus the inner circle. And so it's going to end up being pi r squared minus pi r squared. If you factor the pi out, that leaves you with the two functions squared, because those are the two radius or radii in both cases here. So that's how you would find volume of these shapes. Okay, let's look at this example. It says find the volume of a solid obtained by rotating the region bounded by these two functions and x equals 0 about the y-axis. Well, what's different about this problem? The difference is here, now we're rotating around the y-axis instead of the x-axis. So what's going to change about the problem? Well, let's first graph this out and see what it looks like. So on your calculator, let's type in these functions here and see what it looks like. So let's go to our graphing menu, type these in. So we got y equals 8 is one of them. We also have y equals x to the third power. We can't graph x equals 0. That's a vertical line. It's not a function, but we know it's basically the y-axis here. So this is the region here with the y-axis being part of it. So we get something like this. Here's y equals 8. And we're also using the y-axis too. So we got this, this, and this. So the space in between that we're looking at is right here. If they don't want us to rotate this around the x-axis, we want to now rotate it around the y-axis. Okay, and in doing that, what we're going to get is a figure that looks something like the one shown here. Okay, so if we're going around the y-axis, that changes stuff a little bit, because now our cylinder is going the other way, our cylinder disc. It's still going to be a circle, but our radius is now going this way. It's not up and down anymore. So that would, that's going to be actually an x distance, not a y distance. And so our function now is going to be an f of y1, not an f of x1. That also means when we're rotating this around the y-axis, we need to rotate all these cylinders that would be going vertically from the top down to the bottom here. So our limits need to come from the y-axis, not the x-axis. That's why you see C and D here. So when we're doing this, C and D would be the bottom down here to the top down here would be C and D. Okay, so it's a similar equation, just now we need to get everything in terms of a function of y, not a function of x. All right, so let's see if we can come up with the volume equation to solve this one. It'd be the volume. As we go from, it looks like here, down here, it's 0. And on top, it would be our 8 here of pi r squared. And this one, our radius is going to be this distance. So this distance here is going to be whatever this function is in terms of y. So we know it's y equals x cubed. We need to change that into an x equals equation. So if we find the inverse by taking the cubed root of both sides, we see x is equal to the cubed root of y. So that would be our function here, the cubed root of y. It's pi r squared, so we need to square this like we were doing yesterday. And this is going to be a dy function, not a dx one. So now if we solve this, we should get the answer. Similar to yesterday, we can pull that pi out because that is a constant. We're going to want to think of this y cubed as y to the 1/3 power and then square it here. So we're going to end up with y to the 2/3 power. And now if we find the antiderivative, we can solve it. So antiderivative would be move up 1, which would be 5/3. Reciprocal is 3/5. And we still have this pi here, so I'm going to throw the pi on there too, 3 pi over 5. And then we want to evaluate that from 8 to 0. So now if we plug in those two numbers, we should be able to get it. So I'm going to keep the 3 pi over 5 out till we multiply. So we'll have 8 to the 5/3 power minus 0 to the 5/3 power. 0 to the 5/3 power is still going to be 0. 8 to the 5/3 power, you could use your calculator or use what you know about exponents to do that. If we do 8 to the 5/3, should get 32 for that. So you get 32 multiplied by this would be the answer. 3 times 32 is going to give us 96 pi over 5 would be the volume of this problem. So if you're going around the y-axis, that's how you need to adjust your problem. Okay, similar, if you have more than one function and you want to find the volume created by going around the y-axis, then just like we did with the x, you need both of them. Now in this case, you want to kind of think of this like we did before here. So if we kind of look at it, think of it this way, you're going to want to do like the one furthest away minus the one that's closer. So now if we look at this back how it was originally here, you're going to want to take the one that's further away. So the one that's further away from the y-axis is that one minus that one. So you still want to kind of do top minus bottom, but when you're spinning this here, it's going to be, or end up being kind of the one on the right minus the one on the left. All right, so to solve this one, our volume is going to be 0, because that's the lowest spot here, to 1, because we're going along the y-axis. Everything's got to be in terms of y here, because we got dy. We got our pi again, and now we want to put in our two functions squared. So the one further away is this line. That's this. But we don't want to put x squared in here. These got to match up. And so we need to change that. So we need to change that into something with y. So if we find the inverse, we can do that. Inverse here would be that x would equal, we got to square root both sides, so it looks like square root of y. So that function squared minus, now the one closer is this. We want to find the inverse too. So if we square both sides, it looks like y squared. So now we want to solve that through. Pi again can be pulled out. Let's square both of these. This is going to be y to the 4th. This one's going to be absolute value of y. Since it's all dealing with positive though numbers, we can again think of that as just y. So let's find antiderivatives here. That'd be 1/2 y squared. This would be 1/5 y to the 5th. We still got to pull along our pi here from 1 to 0. If we put in 1, we're going to get 1/2 minus 1/5. If we put in 0, it's just going to be 0. All that times pi. And so 1/2 minus 1/5, we could get common denominator there of 10. And it looks like we get 3 pi over 10. This should be 10. So 3 pi over 10 would be the volume. All right. Let's have you guys try one here. So we'll read through it and then see if you can write down what you think this one is. So it says, let R be the area of the region bounded by the function shown here. Find the volume of the solid formed by rotating around the y-axis. Now, in order to graph these, you're going to want to get them as y functions here. So this one would equate to, if we divide both sides by x, y equals 4 over x. This one, if we minus x, would be the same as y equals negative x plus 5. So use those to get a graph of the picture, but then also know if we're rotating around the y-axis here, eventually you're also going to need to know what these same functions are as x equals functions when putting them in here. So why don't you pause this video, see if you can graph this out and try to come up with a volume function and then start playing it again to check it. All right, so if you type these functions in and graph them, you get these graphs here. So you can see, it looks like the area in between here, where these two graphs intersect, is that little kind of moon-shaped thing there. And we're rotating around y-axis here. So we want this one in terms of y. So our function needs to, looks like the lower one needs to be here, the upper one here. And it appears, at least from my graph, that it's going to be 1 and 4. Now, just like we did before, you can see where these are going to intersect if you put them equal to each other. So if we were to put these two equal to each other, you can find that out. But we need these in terms of x to do that. So we want to solve both of these for x. If we solve these for x, this would be the same as 4 over y. Here, this would be the same as negative y plus 5. So if I put those equal to each other and solve it, you could times both sides by y. And so if we times this by y, it's going to be negative y squared plus 5y. Let's move everything to the same side. And then if we factor that, that's going to factor to y minus 1 and y minus 4. And so it looks like the two places that they do intersect is 1 and 4. So it looks like we did have them right from the graph there. All right, so continuing on here with our volume function then, pi. And now we need these two functions squared and subtracted here. And we want the one that's further away from the y-axis minus the one closer. The one that's further away here is the straight line, which is negative y plus 5. The one that's closer to the y-axis right here is the curved one of 4 over y. So if we solve that out, it should give us the volume here. Let's see what you get. So why don't you pause the video again and see what you get when you solve that now. All right, so if you pull the pi out, you got 4 and 1. Now, you got to be careful here squaring this. Don't put y squared plus 25. That's not what this equals squared. If you're going to square that, you're going to have to multiply two of these together. Negative y plus 5 times another negative y plus 5. Minus, and this other one, we can square both the top and bottom. It's going to be 16 over y squared. Multiplying that out, you're going to get y squared minus 5y minus another 5y, so minus 10y plus 25 minus 16 over y squared. Then we want to keep solving here. On this one, let's use calculator to kind of see what we get. Remember, you can do these y ones just like you would with x with the calculator. To calculate it out, it's just you got to put x in the calculator. So I'm going to get that integral one. We're going to do it from 1 to 4. I'm not going to put the pi in. We pulled that out. We'll keep that out and we'll multiply it back in later. So you got x squared minus 10x plus 25 minus 16 over squared. And then we'll put in our X here. This should give us the same values if it was Y. So it looks like it turns out to be 9. Now, here's where you got to be careful. Answer's not 9. Now we need to make sure we pull with our pi here. So the answer would be 9 pi is the volume. Okay, so that's what you do when you go around the y-axis. I want you to try some more of these out. These were the ones you got yesterday. See if you can now do these additional 5 problems here.